So in this video, we're going to graph another rational function, but this time we're going to graph a rational function with a quadratic in the numerator. Again, the first step is to just simply identify the asymptote. Remember, those are our limit lines. If you didn't watch the previous video, I had a Gandalf reference there. It's, the line that you shall not pass. Okay, so we have a vertical asymptote. This is very, very similar to the last video. A rational function in simplest form has a vertical asymptote at the zeros of the denominator. So the vertical asymptote has not changed. We're still going to set the denominator equal to 0, figure out what it's not allowed to be, and that is our vertical limit line. Okay. The slant asymptote, because we had horizontal asymptote when we had just a linear function over a linear function, but now that we have a quadratic, we're going to have a slant asymptote. Basically, it's a diagonal line, right? So a rational function in simplest form has a slant asymptote if the degree of the numerator is exactly 1 greater than the degree of the denominator. And again, just remember, the degree is the highest exponent. So the degree of the numerator has to be exactly 1 greater than the degree of the denominator. So that would be like, you had x squared in the numerator and you have x in the denominator. Okay, that's exactly 1 degree more. Okay, in such a case, the graph has no horizontal asymptote. If this is true, if it's 1 degree greater in the numerator than the denominator, then you have no horizontal. You only have a slant. So the slant asymptote is found by completing the long division and then graphing the resulting line, excluding any remainder that happens. So I'll show you that kind of step on the next one. So when we go to the graph here, so here's our quadratic over our linear function. So we're going to find our vertical asymptote. We're going to take that 3x plus 9 and we're going to set it equal to 0. And we're just going to solve for x here. So I'm going to subtract from 9 on both sides. 3x is going to drop down. The 9's cancel, and I have negative 9. Divide by 3 on both sides. The 3's cancel, so I have negative 9 divided by 3 is negative 3. So there is my vertical asymptote. So that's exactly the same way as when we did a linear expression over a linear expression, okay, or function. But now the slant asymptote, we needed to look at the degrees. So I have a degree of 2 in the numerator, and I have a degree of 1 in the denominator, because it's x squared and just x. So remember, if it's just x, that means I have a degree of 1. If it was just a number, it means I have no degree, right? Or 0 degree. So I have the numerator is exactly 1 bigger than the denominator, so now I have to use long division to find my slant asymptote, because I need to know what line to graph. We're gonna end up with a line that looks like y equals mx plus b. So I can actually graph that. So here's the long division. So remember, when you're doing long division, what you want to do is you want to figure out, how do I turn this 3x into this first number? I'm not focusing on the 9 or any of these other pieces. I'm just focusing on the first pieces. That's always what you're focusing on. So how do I turn 3x into 2x squared? Well, in order to do this, I'm going to have to use a fraction. I have to multiply 3 by 2/3 x. I do need another x because I have to go from x to x squared. And if I multiply 3 times 2/3, then I will get 2. So you can also kind of use division on this one. If you did 2 divided by 3, you'd end up with, it kind of would help you go backwards a little bit on this to figure out what to multiply by. But it doesn't necessarily give you a fraction when you do that. It gives you the decimal. So you do have to recognize the decimal and turn that into a fraction to make this work correctly. So if I multiply 2/3 by x, 2/3 x by 3x, then I get 2x squared, exactly what I wanted to get. And then 9 times 2/3 x, I get 6x. So remember, when I multiply, I'm going 3 times 2, that's 6. 6 divided by 3 is 2. So I multiply across the top and then divide. Okay, so just keep that in mind. I know fractions are fun. So if I subtract straight down, the 2x squareds cancel. 18 minus 6 is 12. And I bring the x down, of course, and then we bring the 12 down here because there's nothing to subtract from it. All right, so now, how do I turn 3x into 12x? Well, that's simple. I'm just going to multiply by 4, right? And that immediately, 4 times 3x gets me 12x, and then 4 times 9 gets me 36. So when I subtract straight down, I end up with negative 24. Now, this is a remainder. I cannot turn 3x into 24, so I'm done. So here is my resulting division. So the 2/3 x plus 4 from the top, and then my remainder of 24 over 3x plus 9. Now I'm going to ignore the 24 over 3x plus 9. That's not part of what I'm graphing. I wanted this here because this is mx plus b. So now I'm going to start at 4, I'm going to start at 4, and I'm going to go up 2 over 3, and that would be my 2 points, and I would graph this line here. Okay, so this is just my slant asymptote, my diagonal asymptote. Okay, so now I'm going to pick 2 points to the right and 2 points to the left of the vertical. Okay, the slant asymptote does give me a limit line, but when I'm choosing points, I'm just focusing on the vertical. So I'm going to choose 2 points to the right, so I have -2 and -1, and then 2 points to the left, -4 and -5. So just kind of stepping out one each is perfectly fine. You don't need to go too far. In fact, going too far might give you numbers that are outside of the graph area. Not wrong, but if it's outside of the graph area, if it's bigger than 8 on any of these, you can't graph it because it's not a big enough window to graph it. Okay, so we're going to plug in -2 first. So here's my -2 on all of these. So I have 2 times -2 squared, 8 times -2 plus 12, and then 3 times -2 plus 9. So with this one, -2 squared, well, that's +4 times 2, well, it's going to get me 8, right? And then 18 times -2, that's where the -36 came from, plus 12 just kind of came down because nothing happens there. 3 times -2 is -6, plus 9. And then I have 8 minus 36 plus 12, and that's -16. -6 plus 9 is 3. And I'm going to leave this -16 over 3. I'm not going to reduce this because this would give me a very funky decimal. I want to be able to graph it just like this. So you're going to have to click the coordinate graphing tool. It looks literally like a little coordinate with a little X in it. It's just the tool that helps you graph fractions, right? Because you can't actually graph a fraction with the pencil tool. All right, let's plug in 1. You can see I've put 1 on here, so you can see this is where it lands with that one. So now when I plug in 1 here, I have -1 squared, which is 1 times 2, which I get 2. 18 times -1 is -18. And then 12 drops down. -1 times 3 is -3 plus 9. So now when I add across the top, I get -4 over 6. I can reduce that to -2 over 3. So, you know, it's reduced. Means the same thing. If you typed it into the plotting feature, it's going to definitely graph either one of these correctly. So here it is. You can see it on the graph. So I have my 2 points on the right. Now I'm going to go my 2 points on the left. Okay, so I'm going to plug in -4. So -4 squared is 16 times 2 is 32. 18 times -4 is -72 plus 12. And then 3 times -4 is -12 plus 9. When I add across the top, I get -28 over -3. The only thing that's going to cancel are the negatives here. It's going to be +28 over 3. So here it is. It's way up top here. And then I have my last one. So -5 squared. That's 25 times 2 is 50. 18 times -5 is -90. The 12 drops down again. And then 3 times -5 is -15 plus 9. When I add across the top, I get -28 over -6. So again, the negatives cancel, and I could have also reduced that. I don't know why I didn't. I could have divided both by 2 and gotten 14 over 3. So I'll definitely fix that after this video. It's not a big deal because it still graphed it correctly when I typed it in. It really doesn't matter if you reduce the fraction or not. It's still going to graph it just fine for you. And then you click the graph a function feature, and it's going to give you your 2 swooping lines. So remember, this is called a hyperbola. We'll learn more about this later. It's the same idea when we graphed that on the last one. I just didn't give you the name of it. But this is the idea of a hyperbola, where it's almost like 2 quadratics going opposite directions of each other. They're not perfect quadratics, but kind of that idea. Or parabolas, if you want to think of them that way. All right, so this was graphing a rational function with a quadratic in the numerator. I hope that helped, and I'll see you in the next video.